Hello everyone, super happy to be here. I will present you a feedback on how we build a web application involving a huge amount of data. As I say in the abstract, no magic, no hype, no trendy technology here, just boring architecture and well-known technique. So first of all, I will introduce myself, if the slide want to move. There is some latency, I don't know why. Okay, my name is Karim Pinchon, I'm a French backend developer. So what are at the agenda today? First of all, I will present the context, because it's important to know the context, the business context, to put some technical solution against it. I will talk about data, then I will have a word about code, of course, and a little conclusion. So the context, I work for a company called NIQ. It's a US company. In my team, we build a SaaS in a B2B context. And it's basically made for have insight about shoppers and about market measurement. And my team works only on digital purchases, not physical one. We have to work with 5 different industries. So e-commerce, food delivery, so Uber Eats or Just Eat or something like that. Ride, which is transportation services like Uber. FMCG, so fast move consumer goods. So all the products sold quickly and at low cost, like soap, shampoo, snacks, soft drinks, and so on. And BNPL, so buy now pay later, so financial services like Klarna, for example. Here are some of our biggest clients, so Uber, L'Oreal, Coca, Amazon, and so on. Just for you to have an idea of what kind of application we have, here I put some of our analysis, so each analysis for a page. So here, for example, is just, again, an example of the market share analysis, so it speaks for itself. We have also some this analysis, so it growth indexes, so it basically show the market evolution, and we can compare it with other, of course. This analysis, the next analysis is for a consumer switch. Wow, so much latency. I'm so very sorry. I don't know why. Well, just listen to me. The next analysis is for customer switch, so to study customer loyalty and provide insight about behavior of the shoppers. Wow, so the first, this one. Okay, this one is an analysis to simply display a lot of different KPIs about, again, shoppers, merchants, brands, and so on. And all this analysis could be, of course, parameterized with some filters. We have a lot of different filters, and of course, we have you can set a date range. So, for example, you could have your analysis for the last 7 days, or the past months, or the past years, and so on. And for our clients, the stakes of this data is very important, especially in a high-volume consumer period, like Black Friday, for example, or Christmas, and so on. This is very important for our client to make decisions based on that. Currently, we have data in more than 50 countries. We have data about 7 million shoppers. 1.5 billion orders, and all this data represent approximately 1 petabyte of data. Well, okay. So let's talk about data now. So first of all, I'm not a data analyst, neither a data engineer. So I will present this part because it's very important, but not very deeply. Okay, how do we process the data? Sorry. Okay, how do we process the data at NIQ? I did a little diagram, not so interesting, but still. Okay, this will be difficult. Okay, well, listen to me just. So we start by data acquisition. So we will get the data from different sources and put it in a raw format in a MongoDB. Then we have a second step, which is called data structuring. We will structure the data from this raw data to a BigQuery. Then we get a third step, which is data enrichment, and we will make some link between data and fix some stuff. And finally, we will obtain what we call the flat tables, so some kind of big tables. It will be difficult. Okay. Oh, maybe better this way. Okay. This is the scheme. So the first step, the data acquisition. So we get the data from several sources. We have a lot of different parsers to get the data from these sources and put it in Mongo. Of course, we have to update this parser a lot because from one sources to another, the data is totally differently structured. Then we have the data structuring step, which will transform the data and structure it to set it in a BigQuery. After that, we have an Airflow process to enrich the data, so fix the bias we can find, add some data like location, add more data on shoppers, on brands, and so on, and do other stuff. And finally, we will have our flat tables. So our flat tables will be split by industry, you know, the 5 I presented you before, and by countries. So we will be able to go from 1 petabyte of data to a lot of tables, but with some teras. So it's quite less and easily queryable. So why this strategy about flat tables? First of all, the data structure of each industry is very different, from e-commerce to food delivery, for example. So it couldn't match in a one table. The data volume discrepancy. We have a lot more data in e-commerce than in buy now, pay later, for example. We have a limited number of industries and of countries. So in terms of business, it's totally okay. We have this number of tables under control. And it's totally business compatible because, and in fact, it's even easier for us as developers to give permission to our clients to access to some data. Because generally, a client pays for one industry in some countries, not all of our data. So this way is totally okay for us. Okay, now let's talk about code. What kind of architecture we set to exploit this data? And I must say what kind of boring architecture we set. Okay, so we have currently an Apache web server, we have PHP, we have a MySQL database, we have a Redis for cache, we have BigQuery, of course, and AWS SQS for message broker. So not so much exciting, right? Maybe we could switch from Apache to Nginx. It could be better for us, but for now it's okay to use Apache. So we have no really interest to switch our stack. For the technology, for the language, we have just a monolith written in pure PHP and pure JS with just a little bit of Vue.js. So again, not so much exciting, but it works for us. It works for our needs, and all is under control like that. So what can we do to process so much data with this poor stack? I use what I call the big three. So as a French sport lover, I choose 3 of the biggest Dutch sportsmen. I think I'm pretty much okay with Anton Gezink, Johan Cruyff, and Peter van den Hoogenband, right? And to be fair, I choose also 3 sportwomen, amazing sportwomen, like Inge de Bruyne. So the first one of my big 3 is caching, of course. But cache is not a revolution. It's already used a lot in a lot of applications. And we overuse cache in our application. Why caching is important? It's always nice to have cache in any web application. But for us, it's an absolutely necessity for 2 main reasons: for performances and cost savings. Here, I just put an example, a dummy example of what it can take in seconds to display a random analysis in our application without cache and with cache. Here is 26 seconds, but we have some very big analysis which could take more than 1 or 2 minutes to be displayed. So of course, with cache, it will be way more rapid. Also, for cost-saving reason, BigQuery, as you may know, is so expensive. Each time you get data from BigQuery, you will pay. So if we don't call BigQuery, we do not pay. So all the data come from BigQuery. Generally, we put it in the cache, and the next person, the next user who will just ask for the exactly same analysis will have the data from our cache system and not from BigQuery. And there is a bonus to use that, is resiliency. What if BigQuery is down or even slow, and it happens sometimes? Well, for us, is almost no problem, because the majority of the most wanted analysis the data is already in cache. So we don't even ask BigQuery to get the data. Okay, but how we manage our system? By using a trendy technology? Well, of course not. We do not use some shiny stuff like Varnish or something like that. We just have a simple Redis. Well, Redis is an amazing technology, right? But we just use Redis and a piece of code, a piece of PHP code. So I put just a piece of code here. It is basically what we do. We just have this kind of code at the beginning of our API endpoint, and it will just compute a fingerprint based on the analysis, all the filters, the data range, and so on. Get in the cache if there is already something. Return if the response is in the cache, or otherwise, it will just execute the request, get the data from BigQuery, and set it in the cache. So the benefits of our system is stupidly simple, but it works perfectly also. It's flexible, and we have fine-grained management. We do exactly what we want with our cache, and this is what we want to have. But there is also some drawbacks. There is a maintenance cost, because all the code you write, you need to maintain it. It could be less reliable than an out-of-the-box system, again, like Varnish, because we are not specialists of cache. It is definitely slower, because it goes deeper into our stack. But it's acceptable for us. And of course, it consumes a lot of resources for put a lot of data in our Redis. There is some important note to notice is about cache. The first one is duration. Again, it depends of the business you have, but for us it's so easy to set that, because we have a refresh data each week. So we can basically put all the data we want in our cache system for a week, and then invalidation comes after the refresh of the data. So when we refresh the data, we empty the cache, and the data is fresh in the new cache. So again, for us, for our business model, is totally okay to use cache that way. Last but not least, testing is important. It is important to note that when your application relies as much as hours on the cache system, you need to validate each behavior with the cache and without the cache. Sometimes we have some surprise. Okay, the next of my big free system is asynchronous task. So, okay, now. So why async is important? Sometimes treatments are just too long to be executed in a synchronous way, or cost too much resources. So this is at that moment, you have to use asynchronous task. Okay. Keep synchronous task too long will lead to slow responses, slow display to the user, and poor scalability. So having synchronous task will bring you scalability, a better UX, and also some resilience, because you have fix and retry possibility. Asynchronous processing will just basically execute tasks in the background, and during this time, the user will continue to have all the data you want in a synchronous way for another analysis. For example, we have a feature where the user can export a lot of data in a XLS file or in a CSV file, and it could be really huge. And it could take 1 hour or 2 hours to generate the file. And of course, it won't be able in a synchronous way. Again, our stack is so simple, and we want to keep it like that way. We have just a message broker, so here is SQS, but it could be RabbitMQ or something else. And we have just some workers in PHP who will process the message. Well, I just put a piece of code here. It doesn't bring any interest to this talk, but it is basically what we have in our code behind some of our buttons in the application. We just have to build a message with all the data we need to process a task, and just publish it, and it will work. So even in a code way, this is very interesting. okay, what are the benefits of asynchronous task? Of course, the scalability, like I said, the resiliency, because if something failed, you can retry and retry and retry. We can even fix, deploy the new code and not fix in production and retry at this time. So you can basically not lose any message. So if you are quick enough, the clients will not notice there is a problem. And it's not blocking, so the user can just ask for this very big export and continue to exploit another analysis. Okay, the last one. Okay, no image, no problem. The last one is short polling. Again, I warn you, no shiny stuff here, just short polling. And the better explanation for what short polling is just this GIF, I think. But basically, the client part, so the JavaScript, will just loop and send a request to the backend and ask for the response, for the answer, is the treatment done or not, or in progress, and loop and loop and loop, again and again, almost indefinitely until achievement. By opposite of long polling, short polling will bring some advantage, and wow, for the video it will be difficult, I think. But basically, short polling comes works good in tandem with some steppers like that in the UX, because it's important to show to the user that a very long query is in progress, and the user will wait more easily if you notice it, if you notice him that the process is still running. Maybe we will have the end. Okay, what are the benefits of short polling? It's so easy to implement. Basically, it's just a JavaScript loop and a HTTP request. We have also some resiliency coming with short polling, because sometimes if a BigQuery is too slow to answer, just a long polling will end up in a timeout, and with short polling we do not have this kind of issue. So the user will wait a long time, but at the end he will have his analysis displayed. But there is, of course, some drawbacks. The first one is the server load, because you will call a lot your server. And there is some latency, because between each call, you will not have the data as soon as possible. So maybe we can do better and use a server-side event or WebSocket, maybe. The benefit will be to save resources, because no call, no indefinite call to the backend, and we have less latency. Oh, a little typo. There is less latency, because with SSE or WebSocket, we will have some real-time answer. But this is definitely more complex to implement. And for us and for our customers, the short polling is enough for us right now. So, okay, it's time to conclude. The first thing, we can use the free, the big three, but if you haven't built a smart read model, it won't work. It won't do anything. The second thing is to defer processing as much as possible by using and abusing asynchronous task. Cache what you can, it's obvious, but it's very important in any application, and particularly in ours. And at the end, I just want to say that we love this kind of conference and tech event and so on, and we learn a lot of shiny stuff. And back to the job Monday, we will want to use it, but it could not be for the best reason. It could be just to please yourself and not to bring a value to your application. So maybe keep your application as simple as possible is the right choice here. Thank you.